in this video, we're going to do some extra examples looking at functions. So how do you tell if it's a function, the domain and range of a function, how to put functions together, etc. Function notation also. So let's just jump down to the first problem here. I think it's on this page. So if f is the function from the set of real numbers to the set of real numbers defined by the equation f of x equals x squared, we want to find the domain, the codomain, and the range of this function. Okay, so first of all, the domain. So this is the set of allowable x values. Oops. So you want to look at your function equation and say, are there any x values that I could not plug in here? Okay, and when you have a square, you can square any number. So any number I can plug in there, and I'm going to square it, and I'm going to get a y value or an f of x value. Okay, so that means that the domain, there's no bad x's, so the domain is going to be equal to x or the set of all real numbers. Okay, so it's going to be boldface r, or an interval notation, negative infinity to infinity. Okay, so this is the set of all real numbers. Okay, now the codomain, is our target set. Okay, in fact, I am going to add the x here. The codomain is our target, which it says that we're going to r, we're going to y. Okay, so the codomain is just all real numbers as well. Okay, so this is where function was mapped to. Okay, but then the range, for the range, we want elements in the codomain. Okay, so in our target that we were aiming at, that have an x value, so elements y, okay, in the codomain that have x, so that x squared is equal to y. Okay, so these are the ones that actually get mapped to. Okay, now because we're squaring it, okay, x squared, maybe I'll write it here, so x squared, these are our y values. These are always at least 0, right? If you square something, you always get a positive number, a non-negative number, okay? You could get 0. So that means that our range is actually going to be all of the non-negative numbers. So from 0 to infinity. Okay, or you could say the y values that are bigger than or equal to 0. Or to describe it, okay, it's the set of all non-negative numbers. Okay, so this is since x squared is always at least 0 for all x. Okay, so you're never going to get a negative number, so they're not included in the range. Okay, so let's try another one. Okay, so this one is more about function notation. Okay, so here's my f function. I'm going to write it again down here. So f of x, just so we have it, is x squared minus 3x plus 2. Yeah, okay, so that we have it. And then we're going to do these other ones. Okay, so f of x plus h. So remember, okay, so this is our input. Okay, whatever's in the brackets. Okay, so we have these brackets around. So it's f of this thing. So in our function equation, this is where our input is the x. So that's where the inputs go. So everywhere that I see x in the equation, I want to put in my input, which here is x plus h. Okay, so that means that f of x plus h is going to be x plus h all squared minus 3 times x plus h plus 2. Okay, so this is what I put in to where the x's were. So I replaced the purple bits in the equation with the purple bits down here. Okay, that's how function notation works. So it's important that the x plus h is in the bracket, because that's how we know it's the input of our function, which is f. Okay, so this is f of this thing here. Okay, so that's what you want to put in. And now we just have to simplify. So if I expand, this is going to be x squared plus 2xh plus h squared. And then I have to bring the minus 3 through, so it's going to be minus 3x minus 3h plus 2. And I actually don't have any common factors or like terms. So we could just leave it like that. Okay, so that's f of x plus h. Okay, similarly, f of t is, all we have to do is plug in t. So this, instead of x, I'm going to have t. So this is going to be t squared minus 3t plus 2. Okay, f of negative x, again, just plug in negative x. So instead of wherever the x is, so there's x squared, so it's going to be negative x squared, minus 3x, so minus 3 times negative x plus 2. Okay, now if I simplify this, negative x all squared is just x squared, because it's negative 1 squared times x squared, and negative 1 squared is just 1. Negative 3 times negative x is going to be positive 3x, and then I'm going to have my plus 2. Okay, now negative f of x, that's the negative on the outside. So that means I'm going to negate the f of x equation. So I'm not plugging anything special into f, because it just has an x here, right? The negative is on the outside. Okay, so that negative is going to expand through, so it's going to be negative f of x plus 3x minus 2. Okay, so that's a little bit of function notation. Guess I should underline that. Okay, now we're talking about the difference quotient. So we want to find the difference quotient for this function here. So g of x is 3x squared plus 1. Okay, so let's just write the difference quotient first. So it's g of x plus h minus g of x all over h. Okay, that's my difference quotient for the function g. So I want to compute g of x plus h. So x plus h is my input. Okay, so that's going to be 3 times x plus h squared plus 1. Okay, so g of x plus h is all of this. Okay, and then I want to subtract g of x. So that's the regular equation for g of x. Okay, so that's g of x there. And then I have this all over h. Okay, so now to simplify this, I just want to expand everything out. So this is going to be 3 times x plus h all squared is x squared plus 2xh plus h squared. And then I have the plus 1. The negative has to go to both things in g of x, so it's going to be minus 3x squared minus 1. Okay, all of that is over h. Okay, so you have to remember that this negative has to go to both things. And now I need to bring the 3 into all of these things. So that's 3x squared plus 6xh plus 3h squared plus 1 minus 3x squared minus 1 all over h. Okay, now I see some canceling happening. So plus 1 minus 1, 3x squared minus 3x squared. So I end up with 6xh plus 3h squared all over h. And now I think I can factor out an h from the top because there's h's in both terms. And then I'm going to have 6x plus 3h all over h. Finally, I can cancel that h. And so my simplified version for the difference quotient is 6x plus 3h. Okay, so that would be the simplified version of the difference quotient for this function g of x. Okay, so let's try something else. So we want the domain of this function. Okay, so f of x is 1 over the fourth root of 1 minus x. Okay, so the fourth root, of 1 minus x needs the inside bit, 1 minus x, to be at least 0. Okay, so that means that 1 is bigger than or equal to x, because I just added x to both sides there. Okay, so I need that, but the fourth root of 1 minus x is in the denominator. So that means that it can't actually be 0. Right? Because I can't divide by 0. So we actually need the inside bit to be strictly bigger than 0. Okay, so the fourth root of something is equal to 0 when the inside bit is 0. Okay, so we just get rid of that 0 bit, so that means that we need 1 to be bigger than x. Okay, so the domain here in interval notation is going to be negative infinity to 1, but not including 1. Okay, because we have to be strictly bigger than 1, so we don't divide by 0. Okay, so now one more big example where we're combining a bunch of functions. Okay, so I'm going to start by doing the domain of f. Okay, so we need to find all these functions and also their domains. So to do that, I want to know the domain of f and g. Okay, so the domain of f, I can't have the bottom being 0. So I need x plus 1 to not be 0, which means that x cannot be negative 1. Okay, so in interval notation, that's negative infinity to negative 1, and then negative 1 to infinity, where I don't include negative 1 in either of those. Okay, what about the domain of g? Okay, so here I need the bottom, again, x minus 2 to not be 0. So that means that x cannot be 2. Okay, so it looks similar. It's going to be negative infinity to 2, union 2 to infinity. Okay, now if you want to think about these, let me make this a bit smaller. Okay, if you want to think about these on a number line, okay, so I'm going to have, say, negative 1 here. And down here, I'm going to do another one, but I'm going to have 2 on it. Okay, so for f, we can be anything except negative 1. So we have a hole around negative 1, and we can be anything else. For g, it's the same, except that it's at 2. Okay, so we can be anything except 2 there. Okay, so we want to keep that in mind. But first, let's compute the functions, and then we'll talk about the domain after. So we want to compute f plus g of x. Okay, so that's actually f of x plus g of x. Okay, so all we have to do is add the functions together. So it's going to be 1 over x plus 1 plus x over x minus 2. Okay, now if you want to combine these, you'd have to make a common denominator. So we'd want to multiply this one by x minus 2 over x minus 2, and this one by x plus 1 over x plus 1. Okay, and that would give us common denominator of x minus 2 times x plus 1, and we'd have x minus 2 plus x times x plus 1. So we'd have x squared plus 2x minus 2 over x minus 2 times x plus 1. Okay, now again, I'm going to talk about the domains at the end. So let's do f minus g of x. So that's going to be f of x minus g of x. So then I just subtract them. So 1 over x plus 1 minus x over x minus 2. And again, you can do the same thing we did up above, common denominator. It's going to be x minus 2 minus x times x plus 1 over x minus 2 times x plus 1. And that's going to simplify to negative x squared minus 2 over x minus 2 x plus 1. Okay, now it wants us to do f times g of x. So that's just f of x times g of x. So that's going to be 1 over x plus 1 times x over x minus 2. And when you multiply fractions, you multiply straight across. So that's going to be x times 1, or just x, over x plus 1 times x minus 2. Okay, lastly, we have f over g of x. So that's f of x over g of x. So that's going to be 1 over x plus 1 divided by x over x minus 2. So we're going to want to flip the bottom one and multiply. Okay, so we have 1 over x plus 1 times x minus 2 over x, which is going to be x minus 2 over x times x plus 1. Okay, so there's all of your functions. Okay, now I want to talk about the domains. So for the first three, okay, so when you combine, I didn't quite get far enough. When you combine using addition, subtraction, or multiplication, okay, the domains are just the intersection of the f and g domain. Okay, so the domain for all of these is going to be the domain of f, so x not equal to negative 1, and x not equal to 2. Okay, so if you think about the pictures, okay, so we have our number line, we have negative 1 on here, and positive 2 on here. The domain, basically I have to pluck out this value and pluck out this value, but everything else is in the domain. Okay, so it's going to look like that, which means in interval notation, we would go from negative infinity to negative 1, take out negative 1, and then we go negative 1 to 2, and then 2 to infinity. Okay, so when you want to add or subtract or multiply two functions, you just need the x values to be in the domains of each of the functions. Okay, now the quotient is a little bit different because for the domain, we need to be in the domain for all the others. Okay, so we need x not equal to negative 1 and x not equal to 2, but we also need g of x not equal to 0. Okay, so g of x So we want to solve where it is 0. Okay, so that's when x over x minus 2 is 0. So that happens when the top is 0. Okay, so when x is 0, we're going to get a 0 there. So that means that the domain, I'm going to do it over here. So for the division, f over g, the domain is x not equal negative 1, and x not equal 0, and x not equal 2. Okay, so in interval notation, we're going to go negative infinity to negative 1, and then negative 1 to 0, and then 0 to 2, and then 2 to infinity. Okay, and again, if you want to draw it on a number line, you just have to include all 3 of those points. Okay, so we're going everything from negative infinity up until negative 1, and then we continue until 0, and then we continue until 2, and then we continue there. So you just have to be sure when you're doing the division that you remember that you can't divide by 0. Okay, so that's where you have to add in the extra condition that the denominator is not 0. Okay, so those are some extra examples dealing with functions, so function notation, combining functions, domain, etc.